All right, class. Today we're going to discuss stacks and queues. Very simply, a stack is just a data structure to store and retrieve information. Now, if you want to kind of imagine it like a set of books, or boxes or anything like that, it's pretty much the easiest way to think about it. There are two operations you do on a stack. One is push, which puts something on it. The other is pop, which takes something off. Now, the rules of a stack basically follow that you can only basically touch the top thing of whatever the stack is, whether it's a book, whether it's a box, whether it's variables or whatever else. I actually can't do anything with anything underneath the first one. So if I want to get to the bottom of this stack, I have to take everything off the top of it until I get to the bottom. If I want to put something on the stack, then it has to go on the top. I can't just shove it in the middle of it. That's basically how a stack works. Now, there's a couple of nice little games actually that kind of involve a stack I may go over later, but Towers of Hanoi is kind of an interesting one here. There you go. You've probably seen this in games or just in a couple other places. I've seen actually some video games that use something similar as like a mini game. But basically, the idea is this. You have a bunch of disks on the left, and you move them to the far right side. The rule is you can only move one at a time, and a bigger one can't go on top of a smaller one, basically. And as you move them across, it takes, there's actually a formula that tells you basically how many moves, if you did it perfectly, it would take to get across. And if there's just one disk, there's one move. If there's two disks, well, we've got, a couple more, let's say. I'll move that there, this there. I think 3 disk would push it up to like, let's find out. One, two, three, 4, 5, 6, about 7 moves for 3 disks. If we go up to 4, it goes up a very large amount. 5, it goes up even more. But this basically kind of uses a stack. A lot of things actually use stacks. So again, the two moves that you actually do with a stack, the two, I guess you can say methods that you're going to need. One is push, that puts something on the stack, and the other is pop, that takes it off. To give you kind of an example, let's say I have a stack. Well, I push 1 onto that stack, and maybe I want to put 2 on it. Then 2 goes on top of that. And if I push a 3, that goes on top. Now, if I want to take something off, I can only basically just say pop, and it just takes that top one off. And then I have this on the stack. If I push something else, it goes on top of that. Let's say this was a 4 or something. Pop, it comes off. Pop, it comes off, just like that. And where it comes off depends on what you do. I could save it and store it somewhere else, or I could just throw it away, which is what Java does whenever you have a stack of variables. I declared an integer, I declared this, I declared, a string, and then I got to the brace. So we just throw all those things away. That's one of the reasons you got scope, where things don't exist anymore when you hit that brace because it popped everything off. Now, the other data structure is basically your queue, and it is exactly what you think it is. It's a line. This is used, again, for servers, for physical lines, things of that nature. It's used for simulations. There's a big market for people to program simulations for like restaurants and shipping, package delivery. Look at Amazon, for example. That there has to be some coordination. You can't just grab a package and throw it out the window. You have to know what packages need to go first, what need to go second. Packages need to come in, they need to come out. There's all kinds of routing back and forth. People have to go and retrieve them and put them in a truck, and then it has to get delivered. Tremendous amount of programming goes into something like that to streamline it and make sure it works. But basically a queue has two different operations, just like a stack does. It has in queue, which means you put somebody in line, and DQ, meaning you take somebody out. Now, the difference between these two, the stack, as we saw a minute ago, and it helps if I grab that, there we go. I put this thing on the stack, whatever order it goes in, push, 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 and it gets put on the stack. This is what's called last in, first out, or LIFO is the acronym for that. So the last thing in is the thing that I take out, right? A queue, on the other hand, let's say this is my queue. 1 goes in line, 2 follows behind it, 3 follows behind it. Now that is in queue. I'm putting them in line until we basically either fill up the line or, there isn't a fill. It just goes on forever. Eventually, a line's going to be so long, like customers are not going to want to stand in it. And there are simulations for this. Look at Walmart, for example. Perfect example of how often do you go to the store, whether it's Walmart, grocery store, whatever, and you look at the lines and you decide which line you're going to step in, right? The shorter one usually. I don't often all the time step in the shorter one. I often look at see, who's the register, how fast they look, how many items are there. If this line to the left has 2 more people, but the register seems like they're faster and they all have less stuff, I might get in that one. And then it's a race to see if I was right or not. But DQ takes the first thing out. And then this guy or girl or whatever box is now the first in line. And they're the next one to get taken out. Now, of course, traditionally I can't have somebody just cut in line. If they get in line, they go to the end. That's basically the rules for this. And this is called first in, first out, or FIFO. So LIFO is last in, is the first out, and this is the first in, comes out. So those are your 2 particular data structures we're going to be covering. And the 2 big things, we have in queue and DQ. Those are going to be the actual methods we're going to have to make for those. Of course, there's a couple of others. Maybe we want to print the stack. Helps if I spell this right. Or display it or something like that. We can call it whatever we want. And of course, over here, we've got our push and our pop. Basically input and output. Put it in, take it out. And of course, we probably want to be able to display or print that thing so we can see what the stack looks like. And generally speaking, this is kind of how I view a stack because it's stacked up, and this is kind of how I view a queue, with this being the front and this being the back. Now, some stacks and queues would have also what's called a variable that points to the top, or a variable that points to the first person in line. And there are several different ways you can actually make this. I could probably make it so, I have the first person in line. Maybe we want to incorporate, people leaving because it takes too long. Surely you've been in a restaurant like McDonald's or Wendy's or Burger King or whatever, and there's a line. And you always get somebody who is impatient. The line's long, it's taking too long, and they just balk. They walk out. That would be a whole other set of programming. It might not necessarily be the person at the very end. It might be somebody in the middle. I've been at a Subway where a guy was walking up there and they asked him a question and he just went poof and walked out. I was like, well, he must be having a bad day. But it's a good day for me because I moved up one place in line without having to wait. Yay. One man's loss is another one's gain, I guess. But these are stacks and queues. Now, as usual, Java has these built in. But to know how they work, you really have to program them yourself. Once you have programmed them yourself and you know how they work, then don't do that ever again. Just there's no reason for you to reinvent the wheel. It's there. Java has it, or C++ has it, C Sharp. You can just import it and use it, and you don't have to worry about it being broken or screwed up. All right, well, that is basically your overview of stacks and queues. Now, from a data structure standpoint, we're actually going to use some arrays for this to sort them, and those arrays are going to have some rules. But you'll see a little bit more of that when we actually create it.